Most of the time we're given functions of x rather than functions of y. In this case we've been given a function of y. And this is a surface that's being rotated about the y-axis. Well, it is possible that you could solve for y and get a function of x, but I've actually tried that and the integral is very, very difficult. Also, we would then need to change these values to be x values. So we'll just go ahead and use y. There is one small difference. This is being rotated about the x-axis. So usually we would be using this formula, so rotating about the x-axis. So 2 pi, the function, and then the arc length formula. But if you have a function of y, then instead of replacing the function here, you just have the letter y. So we're going to have integrate 2 pi, the letter y, and then 1 plus the derivative, and the derivative is not y prime because we're switching x's and y's. The derivative is actually x prime squared, and then with respect to y. So we need to know what's x prime over here. So x prime, or dx dy, this 3/2 goes over here, multiplies with the 1/3, canceling the 3's, leaving a 1/2, y squared plus 2. Subtract 1 from this 3/2 and it's going to be a positive 1/2. And then the chain rule says take the derivative of the inside, which is a 2y. And then we can have the 1/2 cancel the 2, and then we're ready for this. So integrate from 0 to 2, it says. 2 pi times y, and then the square root of 1 plus, and now we need to square this derivative, which means we'll have a y squared right here, and this radical will be gone. So we'll have a y squared, the radical's gone, there's y squared plus 2. Then multiply this out and get y to the 4th plus 2y squared. That's limit is 0 to 2. And then it's 2 pi times y, the square root, and I'll put them in order, y to the 4th plus 2y squared plus 1. And with these integrals that involve square roots, a lot of them are pretty challenging. This one, though, turns out pretty nice because it turns out this can be factored. This can be factored, in fact, into y squared plus 1 being squared. So just double check the algebra, that works. Great, so then the square and the square root cancel each other out, and we would just have y squared plus 1 times a y. So that's going to be y cubed plus a y. And then, after all that algebra, it's time to integrate. So we would get y to the 4th over 4 plus y squared over 2, and then evaluate from 0 to 2. So the 0 is going to contribute nothing to this, but the 2 will be, this will be 16 divided by 4, and this will be a 4 divided by 2. And so we have the surface area is going to be 6 times 2 pi, 12 pi's.